Hello friends, welcome to Shibi's chemistry classes. Today's topic is variation or trend in periodic properties. In our previous lecture, we have seen all the periodic properties like electron affinity, ionization energy, electronegativity, metallic, non-metallic character, everything we have covered. We have discussed what are these properties actually. Now we have to see how these properties vary in group and period. And first we will see how these properties vary along a period. So I have made elements I have taken elements of period 2 and period 3. In period 2 we know the elements are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. The atomic number are written here 3, 4, 5, 6, 7, 8, 9, 10 and the electronic configuration is written in red. Similarly, period 3 elements, they are sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. So just to explain all the properties, I have made these two period 2 and period 3 elements over here. So on the basis of this, we will try to understand how these properties vary along a period. So in period, we know that we move from left to right and in group from top to bottom. So first we'll see from left to right. So first we'll see atomic size. So what happened to the atomic size when we move along a period? See, here the number of proton is 3, 4, 5, 6, means number of proton is increasing. And that is clearly visible from the structure of the atom. So what happens if the number of proton increases? If the number of proton increases, that means nuclear charge is increasing inside the nucleus. So if the nuclear charge is increasing, it will exert an increased pull on the electrons or the outermost electron that is present in the valence shell. So what will happen? This proton will exert a force of attraction on the outermost electron. ये प्रोटॉन इस इलेक्ट्रॉन को अपनी तरफ खींचेंगे. तो जैसे जैसे नंबर ऑफ प्रोटॉन इज इंक्रीजिंग, दैट पुल इज बिकमिंग मोर एंड मोर. और जैसे जैसे फोर्स ऑफ अट्रैक्शन ज़्यादा होगा, वो इलेक्ट्रॉन को अपनी तरफ ज़्यादा फोर्स से अट्रैक्ट करेंगे. तो एज अ रिजल्ट ऑफ विच व्हाट विल हैपन, द size will decrease. Means along a period, the first element is having bigger size and gradually it will go on decreasing. See the last element, this is the noble gas element, group 18. This we will discuss separately. Okay, neon and argon we will discuss separately in the last. So what I am saying right now is for applicable for lithium to fluorine. So in period 2, lithium has the highest size and it will gradually go on decreasing. Why? Due to increase in nuclear charge. Similar is the case with third period element. Here sodium has the biggest size amongst all these elements except for argon, is because it is a noble gas and it has some another reason. So this size will eventually go on decreasing. Why? Due to increase in nuclear charge inside the center of the nucleus. See here it is 11 proton, 12 proton, 13 proton, means number of proton. If it is increasing, that means positive charge is increasing inside the center of the nucleus. So the size will decrease. It will exert a force of attraction on the outermost electron and it will pull the electron towards itself, as a result of which the size will shrink and it will decreases. What will happen to the atomic size? It will decrease. Second is number of shell. You can see number of shell. It is 2, 2, 2, 2. It is 2 for all the elements because we know that the number of period decide the number of shell. And in which period the element is belonging, that period number is the number of shell. Here the elements belong to period 2, that means it has 2 shell. Elements belonging to period 3, it has 3 shell. But you can see that all the elements are having 3 shell and here 2 shell. That means the number of shell same. It is neither increasing nor decreasing, it remains same. Since the number of shells are same, that means nuclear nuclear charge means the weightage of nuclear charge over this electron is more. See, when we move down the group, there also the nuclear charge as well as the number of shell both are increasing. And here I am giving you the explanation for the decrease in size. And I am saying that size इसलिए decrease हो रहा है क्योंकि nuclear charge बढ़ रहा है. लेकिन हम जब down the group जाते हैं तब भी nuclear charge बढ़ता है, पर वहाँ पे size increase होता है ना, बजाय decrease होने के. जब हम down the group अभी हम पढ़ेंगे डाउन द ग्रुप, तो डाउन द ग्रुप जब हम मूव करते हैं तो एटॉमिक साइज इंक्रीज होता है. वो क्यों होता है? क्योंकि वहाँ डाउन द ग्रुप जाने पे भी न्यूक्लियर चार्ज इंक्रीज हो रहा है, लेकिन वहाँ पे नंबर ऑफ शेल्स भी इंक्रीज होते हैं. यहाँ पे यू कैन सी द नंबर ऑफ शेल्स आर सेम फॉर ऑल द एलिमेंट्स, सो द वेटेज विल बी गिवन टू द न्यूक्लियर चार्ज. तो जो इफेक्ट होगा, ओवरऑल इफेक्ट, वो न्यूक्लियर चार्ज के लिए जाएगा, क्योंकि शेल में कोई चेंज नहीं है. पर जब हम डाउन द ग्रुप जा रहे होते हैं, हम दोनों जरूर बढ़ रहे हैं, न्यूक्लियर चार्ज भी बढ़ रहा है, नंबर ऑफ शेल्स भी बढ़ रहे हैं, पर नंबर ऑफ शेल्स का वेटेज ज़्यादा होगा, क्योंकि जो आउटरमोस्ट इलेक्ट्रॉन का जो डिस्टेंस है फ्रॉम द न्यूक्लियस, इट विल बी मोर. एज अ रिजल्ट, व्हेन वी मूव डाउन द ग्रुप, द साइज इंक्रीजेस. सो दैट विल डिस्कस. So the number of shell is same. Valence electron you can see in the second period 1 2 3 4 5 6 7, and here also 1 2 3 4 5 6 7. That means valence electron increase. Valence electron, what is happening to valence electron? It is increasing. Valence electron, we know that it is the number of electron present in the outermost orbit or outermost shell. सबसे बाहर के shell में जो electron present होते हैं उसको हम valence electron बोलते हैं. लेकिन valency is different from valence electron. What is valency? It is the number of electron that participate in chemical combination, and it is not same as valence electron. So what is happening here? See, valency will increase up to 4, है ना? Valency will first increase up to 1 to 4. Then what will happen? From 6, 7, 8 onwards. 1, 2, 3, 4 valency. From 1 to 4 it will increase, and then 5 to 6 it will decrease. How we will calculate it? We have to calculate it by subtracting this number of valence electron from 8, because 8 is the maximum number of electron that can be accommodated in a shell. So what we will do to find out valency? We will subtract the number from 8. So here it is 8 minus 5, 3, 8 minus 6, 2, 8 minus 7, 1, and the last is 8 minus 8 is 0. So after that, valency decrease, then decrease. First increase up to 4 and then decrease. Clear? Valency is the number of electrons that participate in chemical combination, bond formation. So it will increase till 4 and then it will decrease. Here you can see that the valence electron is 5, but the valency is not 5. Valency is 8 minus 5. Here the valence electron is 6, but the valency is not 6. It is 8 minus 6, 8 minus 7, and 8 minus 8. So this is how you have to calculate the valency. Then next property will take ionization energy. Ionization energy, we all know, it is the amount of energy needed to remove electron from the valence shell. So that also we can see. So we know that size is decreasing when we move along a period. And if the size decreases, what will happen? The outermost electron is attracted with more force towards the nucleus. जो nuclear pull होगा on the outermost electron, क्योंकि ionization energy is what? The amount of energy needed to remove electron from the valence shell, है ना? जितनी ज़्यादा easily electron remove होगा उतना कम ionization energy हमें supply करनी पड़ेगी. But here what is happening? We have already discussed that size is decreasing as we move along the period. जैसे जैसे साइज छोटा होगा, है ना, न्यूक्लियस और आउटरमोस्ट इलेक्ट्रॉन के बीच की दूरी कम हो जाएगी. तो कम हो जाएगी तो न्यूक्लियस और इलेक्ट्रॉन बहुत ज़्यादा फोर्सेस से एक दूसरे की तरफ अट्रैक्टेड होंगे. न्यूक्लियस इलेक्ट्रॉन को अपनी तरफ खींच के रखेगा, तो उसको क्या रिमूव करना ईजी होगा? Will it be easier to remove that electron then? No, it will not be easier. So that means we have to supply more and more amount of energy. So what will happen? The ionization amount of ionization energy will increase. So सबसे कम ionization energy lithium में होगा और जैसे जैसे हम मूव करेंगे along the period it will go on increasing. So ionization energy increase and that means the removal of electron will become difficult. So if you will be asked the question that why the removal of electron is difficult from carbon than lithium, why the amount of ionization energy that is required to remove electron from oxygen is more as compared to lithium. So you have to give this explanation that as the size is decreasing, the nuclear pull exerted on the outermost electron is more, as a result of which it will become difficult to remove electron. As a result, ionization energy will be more or ionization energy will increase along a period. Then we discuss electron affinity. What is electron affinity? First we should know that electron affinity क्या होता है? It is the amount of energy released when an electron is added to the atom. है ना? The tendency of atom to accept electron, that is electron affinity. जितना ज़्यादा electron affinity की वैल्यू होगी उतनी ज़्यादा उस atom को इलेक्ट्रॉन को लेने की चाहत होगी, है ना? So that is the tendency of atom to accept electron and the amount of energy released. So the more the amount of energy released, the more is the love for electron to that atom, है ना? दो उस एटम को इलेक्ट्रॉन को पाने की उतनी ही चाहत होगी, उतना हैप्पी, इट विल फील हैप्पियर टू एक्सेप्ट इलेक्ट्रॉन. Why it is accepting electron? It is accepting electron to complete its octet, isn't it? So trend, what trend is followed? See, the size is decreasing. The outermost electron is coming close to the nucleus. So nucleus is exerting a force of attraction on the electron. So what will happen? It will accept electron easily. तो जितना ज़्यादा easily electron accept हो रहा उतना ज़्यादा electron affinity की वैल्यू होगी, उतना खुश हो रहा है atom इस electron को पाके, तो it is releasing more and more amount of energy. So that means the value of electron affinity is also increasing along a period. Then is electronegativity. It is the tendency of it is the tendency of an atom in a molecule to attract the shared pair of electron. Now how it differs from electron affinity? In electron affinity, we are accepting, that atom is accepting the electron, but in electronegativity it is only attracting. And we have discussed that it is a dimensionless quantity measured in a Pauling scale, and fluorine is the most electronegative element with a value of 4. So electronegativity is the tendency to attract. So tendency to attract कैसे होगा? जैसे जैसे हम along a period we are moving, what will happen? Size decrease हो रहा है, तो न्यूक्लियस और आउटरमोस्ट शेल की दूरी डिस्टेंस कम हो रही है, अट्रैक्शन बढ़ रहा है, तो अट्रैक्शन बढ़ रहा है तो डेफिनेटली इट विल अट्रैक्ट इलेक्ट्रॉन towards itself. So again it increase. So the value of electronegativity also increases. Means ये सबसे कम इलेक्ट्रोनेगेटिव होंगे और हम यहाँ से जैसे जैसे मूव कर रहे हैं, फ्लोरीन इज द मोस्ट इलेक्ट्रोनेगेटिव एलिमेंट. But neon doesn't follow this trend, no? यहाँ इलेक्ट्रोनेगेटिविटी की वैल्यू इंक्रीज हो रही है, but suddenly decreases in case of neon. That we will discuss. Okay. Then comes metallic character and non-metallic character. We'll see metallic and non-metallic. So what are metals? What are metals? Metallic character. So what are metals? Metals are the elements that have tendency to lose electron. And those elements, those who can donate electron easily, they comes under the category of metals. So who will donate electron easily? See, in this period, the lithium is having the highest size. Lithium का size सबसे बड़ा है, एंड एज वी मूव अलोंग द पीरियड द साइज इज डिक्रीजिंग. सो जैसे जैसे साइज डिक्रीज होगा इट विल नॉट अलाउ द रिमूवल ऑफ इलेक्ट्रॉन इजीली. But in this period, who will allow the removal of electron easily? Lithium. और थोड़ा कम beryllium. और थोड़ा कम boron. But as we move along the period, this tendency decreases due to decrease in size and increase in the nuclear pull on the outermost electron. So what will happen? The metallic character also decreases. Metallic character decrease. And metals form basic oxide. This you have to keep in mind that all the metals they form basic oxides. So if the metallic character is decreasing, then basic oxide tendency to form basic oxide also decrease. This oxide, acidic oxide, basic oxide, this you will study in details in your third chapter. Acid and bases, acid base and salt वाले chapter में हम इसको detail में पढ़ेंगे. For now, you should know that metals form basic oxide, and if the metallic character is decreasing along the period, that means the tendency to form basic oxide also decreases. Now, non-metallic character. So, if the metallic character is decreasing, that means non-metallic character is increasing. Why? Non-metals क्या होते हैं? Elements that have the tendency to accept electron, and we have already seen that these elements they are accepting electron, है ना. वो octet को complete करने के लिए वो accept करेंगे. See, it is having 7 electron in its valence shell. It needs 1 more electron to complete the octet. So rather than donating 7 electron, it will accept. It will be easier to accept 1 electron. So this is accepting 1 electron. Here it is short of 2 electrons, so it will accept 2 electron. Short of 3 electron, it will accept 3 electron. Short of 4 electron, it will accept 4 electron. But what happened here? It will not accept. It will donate this 3 electron. It will donate this 3 electron and complete the octet and complete the duplet. So it will gain the electronic configuration similar to noble gas and become stable. So we have seen that the tendency to accept electron is increasing. That means non-metallic character is increasing. So we will write non-metallic character increase. So non-metals form acidic oxide. So it will also increase. See, non-metallic character is increasing. That you can see from here. This is metal, metal, metal. ये तीनों metal हैं. No, this is not metal. Boron is metalloid. है ना? Like metal, metal, metal. This is metalloid. Sodium is a metal. Magnesium is a metal. Aluminium is a metalloid. Sorry, aluminium is metal and silicon is metalloid. Then non-metallic character increase. These are non-metals. ये सब क्या है? Non-metals है. ठीक है? Anything is left? Yes, noble gas. Now we have to see noble gas. First, सबसे पहले देखेंगे हम atomic size noble gas का क्या है. Trend क्या कहता है? Along a period, what is happening to the atomic size? Atomic size is decreasing. We have seen that according to the trend, the atomic size is decreasing as we move along the period. But this neon or argon, they will not follow this trend. क्योंकि जैसे जैसे हम देखेंगे साइज यहाँ तक तो डिक्रीज हो रहा है, बट सडनली ये नियॉन और आर्गन का साइज क्या होगा? बड़ा होगा. So why is it so? So you can see that these elements are having 8 electron in the outermost shell. Their octet is complete, है ना. Number of shell is same, but एक ही घर में एक ही शेल में पूरा इलेक्ट्रॉन पैक हो चुके हैं. So what will happen? इंटर इलेक्ट्रॉनिक रिपल्शन की वजह से साइज क्या होगा? एक्सपैंड होगा. So as a result of which the size of these elements increases. So it will not follow this trend. Decrease in atomic size वाला ट्रेंड यहाँ फॉलो नहीं होगा. ठीक है. मेटल्स एंड नॉन मेटल्स वाला ट्रेंड इन पे फॉलो नहीं होंगे. और क्या था? आयनाइजेशन एनर्जी, वैलेंस इलेक्ट्रॉन. पहले हम देखते हैं वैलेंस इलेक्ट्रॉन. दोनों के पास 8 है. मीन्स नोबल गैस है. नोबल गैसेस दे ऑल हैव 8 इलेक्ट्रॉन इन देयर वैलेंस शेयर. वैलेंसी कितनी होगी? 8 - 8 0, है ना. because they will neither accept nor donate electron. Why they will not accept or donate? Because they are happy, they are satisfied with the electron they are having, because all the atoms they try to achieve this octet. ये octet complete करने के लिए ही तो सारी ये जोड़ तोड़ हो रही है ना? ये जितनी भी ये जोड़ तोड़ हो रही है, जो कंपाउंड्स बन रहे हैं, n नंबर ऑफ कंपाउंड्स आर देयर, है ना? वी आर नोन टू दिस n नंबर ऑफ कंपाउंड. में पता है इतने सारे कंपाउंड्स होते हैं. ये सब क्यों हो रहा है? क्यों? क्योंकि सबको चाहिए 8 इलेक्ट्रॉन्स. They all need 8 electron in the valence shell. So why they will do so? Because they are already having 8 electron. God gifted 8 electron. They are happy with that, है ना? So they will not participate in chemical combination, और उनकी वैलेंसी क्या होगी? 0. ना हमें देना है ना हमें लेना है. आयनाइजेशन एनर्जी, बहुत ज़्यादा आयनाइजेशन एनर्जी लगेगी. ट्रेंड्स क्या बोलते थे? As we move along the period, ionization energy is increasing, है ना? और यहाँ पे आके बहुत ज़्यादा इंक्रीज हो जाएगा, क्योंकि ये इंक्रीज तो हो ही रहा है और इसकी बहुत ज़्यादा होगी वैल्यू, क्योंकि 8 इलेक्ट्रॉन है, तो ये इलेक्ट्रॉन निकालना, ये रिमूव करना, इट विल नॉट allow the removal of electron. Electron affinity trend, according to the trend, the value of electron affinity is also increasing as we move along the period, but suddenly it decreases when we comes to noble gas. Why? Because it will not accept electron. Its tendency to accept electron is negligible. So the value of electron affinity suddenly drops here in case of noble gas. Electronegativity also the same. There is no need to attract shared pair of electron for noble gas, so they will not do so. So I hope this much is clear. Now we will see trends in periodic properties down a group. Along a period we have done, now we will see down a group. Down a group. See, after doing seeing variation in properties along a period, this will be easier for you to understand. We will take first group element, group 1, hydrogen, lithium, sodium, potassium. We'll take up to potassium, atomic number 1, 3, 11, 19, and its configuration is 1, 2, 1, 2, 8, 1, 2, 8, 8, 1. We will draw the structure. 1 proton and 1 electron. Now we'll see all the properties one by one. Atomic size. You can see from the diagram that the size of atom is increasing due to the addition of extra shell. Here it is 1 shell, then 2 shell, then 3 shell, then 4 shell. So as the number of shell increases, the atomic size also increase. Along a period क्या हो रहा था? Atomic size was decreasing, and down a group it will increase. Next is number of shell. This also increasing. Then valence electron. You can see valence electron. You can see from the electronic configuration, the valence electron is same for all the elements. This we have already discussed. In group, the valence electron will remain same, and in period, number of shell will remain same. In group, valence electron will remain same, but it will not remain same in period. It will increase in period, whereas in group, What is changing? Shell is changing, but shell will remain same in period. So these are the very small details that you have to keep in mind, and that will come with practice. The more you practice, the more you will gain confidence in chemistry. And if you will not practice, chemistry will be a difficult nut to crack always, है ना. केमिस्ट्री बहुत डिफिकल्ट, बच्चों को बहुत डिफिकल्ट लगता है केमिस्ट्री. एंड द रीजन इज दैट कि कंसेप्ट जो होते हैं ना, कॉन्सेप्ट अच्छे से क्लियर नहीं होने की वजह से बच्चों को पता नहीं होता वैलेंसी क्या होती है, वैलेंस इलेक्ट्रॉन क्या है ना. तो ये सब शुरू से ही जो अभी जो बेसिक जानकारी है वो आप अच्छे से जब आप पढ़ लेंगे, क्योंकि पूरी केमिस्ट्री इन्हीं चीज़ों पे बेस्ड होती है ना. तो बहुत अच्छे से प्रैक्टिस करना है, एंड देन यू विल बिकम ए मास्टर वन डे. सो क्या पढ़ रहे थे हम? वैलेंस इलेक्ट्रॉन. So you can see the valence electron is same. It is 1 for first group, 2 for second group, 3 for third group, and so on. So it is same. Valency is also same. Then ionization energy. Ionization energy क्या होगा इसमें? It is the energy needed to remove electron from the outermost shell. So as we move down the group, you can see that the size is increasing, so distance become large. Distance between the outermost electron and nucleus is more, as a result of which this electron is loosely held. जितना जितना दूरी होती जाएगी है ना, इलेक्ट्रॉन उतना लूजली हेल्ड होगा, तो इलेक्ट्रॉन का रिमूवल उतना ईजी हो जाएगा. तो एज वी मूव down the group, the value of ionization energy decreases, but along a period ionization energy increase हो रहा था, है ना. Then electron affinity, you can see that as the size is increasing, so the tendency to attract electron also decreases, so this also decrease. And same is for electronegativity, वो भी decrease. Metallic character, basic oxide. Non-metallic, acidic oxide. You can see that as we move down the group, the removal of electron will become easier, and we need that for metals, because metals are the elements that have the tendency to lose electron. So as the size is increasing, the force of attraction decreases, so as a result of which the removal of electron will become easier. So the metallic character increase. Metallic character increase, if it is increasing, then definitely the tendency to form basic oxide also increase, so both will increase. And non-metallic character will decrease, both will decrease. So here we have completed the chapter, first chapter. It is not a very difficult one, and we have covered this whole chapter here. And now in the next video we will take some questions, and after solving questions it will become easier for you to understand what type of questions will be asked from this chapter, isn't it? क्योंकि हम chapter तो हमें समझ में आ गया है, पर जब तक we will not solve the questions, है ना, how we will know that what type of questions are going to be asked in board examination. So that we have to practice. We'll take some previous year questions and we'll solve it. One complete video I'll make for that only. Okay, till then, bye bye.